Imagine Earth, our home, spinning in the vastness of space. It's a pretty big place. To find any spot on its surface, we need a system. Think of it like a giant map, but one that wraps around a sphere. This map uses special lines. We call these lines latitude and longitude. They create a grid, like the squares on graph paper. This grid helps us pinpoint any location, from the highest mountain to the deepest ocean trench. Without this system, navigating our world would be incredibly difficult. It is fundamental to how we understand our planet's geography and so much more. Latitude lines run east and west parallel to the equator. The equator is the most famous latitude line, sitting at 0 degrees. It divides the Earth into the northern hemisphere and the southern hemisphere. As you move away from the equator, towards the North Pole or the South Pole, the latitude degrees increase. The North Pole is at 90 degrees north, and the South Pole is at 90 degrees south. These lines tell us how far north or south a place is. This distance from the equator is crucial. It determines a lot about a place, especially its climate, as we will see. Longitude lines, on the other hand, run north and south. They stretch from the North Pole to the South Pole. These lines are also called meridians. The prime meridian, at 0 degrees longitude, passes through Greenwich, England. This was an arbitrary choice, but now it's a global standard. Longitude lines tell us how far east or west a place is from this prime meridian. They help us understand time zones too. As the Earth spins, different longitudes face the sun, giving us day and night. Together, latitude and longitude give every point on Earth its unique address. This global grid is not just for drawing maps or guiding ships and planes. It's a framework for understanding how energy flows across our planet. The angle of sunlight, the strength of Earth's magnetic field, and even the distribution of life are all connected to these coordinates. When we talk about energy hotspots, we are often talking about specific intersections of latitude and longitude where unique conditions arise. These coordinates are the starting point for exploring the dynamic forces that shape our world, from the weather patterns we experience daily to the subtle energies some believe are concentrated in specific locations. Now, let's talk about something that makes life on Earth so varied: our planet's tilt. Earth doesn't spin perfectly upright as it orbits the sun. Instead, it's tilted on its axis by about 23.5 degrees. Think of a spinning top that's leaning over slightly. This tilt might seem small, but its effect is enormous. It is the primary reason we have seasons: spring, summer, autumn, and winter. If Earth had no tilt, the amount of sunlight hitting any one spot would be the same all year round. Climates would be very different, and life would have evolved in vastly different ways. Because of this tilt, different parts of Earth receive more direct sunlight at different times of the year. When the northern hemisphere is tilted towards the sun, it experiences summer. The days are longer, and the sunlight is more intense. At the same time, the southern hemisphere is tilted away from the sun. It experiences winter, with shorter days and less direct sunlight. 6 months later, the situation reverses. The southern hemisphere tilts towards the sun, enjoying summer, while the northern hemisphere cools down in winter. This constant dance of tilt and orbit creates the rhythm of the seasons. The equator is a special case. Because it's in the middle, it doesn't experience dramatic seasonal changes in temperature like the higher latitudes do. Near the equator, the sunlight is always relatively direct. Places here tend to have warm climates year-round, often with distinct wet and dry seasons instead of 4 temperature-based seasons. The poles, on the other hand, experience the most extreme effects of the tilt. During summer, a pole can have 24 hours of daylight. During winter, it can be plunged into 24 hours of darkness. Svalbard, Norway, and Fairbanks, Alaska are both examples of cities in which this occurs. This axial tilt dramatically influences Earth's energy balance. This tilt also affects the height of the sun in the sky at different latitudes. At the tropics, specifically the Tropic of Cancer, 23.5 degrees north, and the Tropic of Capricorn, 23.5 degrees south, the sun can be directly overhead at noon on the solstices. These latitudes mark the boundaries of the tropical zone. Outside the tropics, the sun is never directly overhead. This variation in solar angle due to the axial tilt is a key factor in how solar energy is distributed across the planet, directly impacting climate, weather systems, and the potential for harnessing solar power in different regions. The sun is our planet's ultimate energy source. It bathes Earth in light and heat, driving our climate and sustaining life. However, this solar energy isn't distributed evenly. Latitude plays a starring role in determining how much sunshine a particular spot receives. Imagine Earth as a giant sphere. Sunlight arrives in parallel rays. Near the equator, these rays strike the surface almost directly, at a high angle. This means the energy is concentrated in a smaller area, leading to warmer temperatures. It's like shining a flashlight straight down onto a table. The light is bright and focused. As you move away from the equator, towards the poles, the sun's rays strike the Earth's surface at a lower, more oblique angle. The same amount of solar energy is spread out over a much larger area. Think of shining that same flashlight at an angle. The light becomes dimmer and more diffuse. This is why regions at higher latitudes, like the Arctic and Antarctic, are much colder than tropical regions. They simply receive less intense solar radiation per unit area. The atmosphere also plays a part. Sunlight has to pass through more of it at higher latitudes, which can scatter and absorb some of the energy. This variation in solar energy distribution drives global wind patterns and ocean currents. The warm, energy-rich equatorial regions heat the air above them. This warm air rises and flows towards the poles. Colder, denser air from the poles then flows towards the equator to replace it. This creates large-scale atmospheric circulation cells. Similarly, differences in water temperature, driven by solar heating, contribute to the movement of massive ocean currents. These currents act like giant conveyor belts, transporting heat around the globe and influencing regional climates significantly. Without this solar energy gradient, our weather would be very different. The amount of solar energy received also affects the length of the day. Near the equator, day length is relatively consistent throughout the year, around 12 hours. But as you move towards the poles, the seasonal variation in day length becomes extreme due to Earth's axial tilt. Long summer days at high latitudes mean more hours of sunshine, even if the angle is lower. Conversely, winter brings very short days or even complete darkness. This dynamic interplay of latitude, axial tilt, and solar energy shapes ecosystems, influences agriculture, and is a critical factor in designing renewable energy systems, especially solar power generation. Beyond the visible light and heat from the sun, Earth itself possesses an invisible force field, its magnetic field. Generated deep within the planet's molten iron core, this geomagnetic field extends far out into space, forming a protective bubble called the magnetosphere. This field is incredibly important. It shields us from harmful solar wind, a stream of charged particles constantly flowing from the sun. Without it, Earth's atmosphere might have been stripped away long ago, making life as we know it impossible. It acts like an invisible umbrella, deflecting most of these dangerous particles. The Earth's magnetic field isn't uniform. It has a north magnetic pole and a south magnetic pole, which are somewhat near but not exactly at the geographic poles. Compass needles align with these magnetic field lines, which is how they help us navigate. The strength and direction of the magnetic field vary across the globe. There are areas with stronger magnetic fields and areas where it's weaker. These variations are known as magnetic anomalies. Some scientists believe these anomalies, or areas where magnetic lines of force converge, might have subtle influences on the environment and even biological organisms. Geomagnetic forces are dynamic. The magnetic poles slowly wander over time, and occasionally throughout Earth's history, they have completely flipped. These geomagnetic reversals are recorded in rocks, giving us a glimpse into our planet's deep past. Solar activity, like solar flares and coronal mass ejections, can also impact the magnetosphere. When these powerful bursts of solar energy hit our magnetic shield, they can cause geomagnetic storms. These storms can disrupt satellites, power grids, and communication systems. They are also responsible for the beautiful auroras, the northern and southern lights, seen at high latitudes. The interaction between the Earth's magnetic field and incoming solar radiation is a complex dance of energy. While the primary driver of climate is solar radiation determined by latitude and tilt, geomagnetic forces play a crucial role in the near-Earth space environment. Some theories, often outside mainstream science, suggest that specific points on Earth might have unique geomagnetic properties, possibly contributing to energy hotspots. While scientific evidence for localized biological effects of these subtle variations is still debated, the Earth's magnetic field is undeniably a fundamental energetic aspect of our planet. Cultural heritage, regardless of the precise nature of physical energy present. On the summer solstice, the sun rises very close to the heel stone, which stands just outside the main circle. On the winter solstice, the sunset aligns with other parts of the structure. This suggests a sophisticated understanding of astronomy. Like Giza, Stonehenge is often considered an ancient energy hotspot. Theories abound regarding its purpose, from an astronomical observatory to a sacred healing center or a ritual site. The bluestones, some of which were transported hundreds of miles from Wales, are believed by some to have special properties. Visitors to Stonehenge also report experiencing tingling sensations, visions, and time distortions. The area around Stonehenge is rich with other prehistoric sites, suggesting it was a significant ceremonial landscape. Whether it harnesses specific Earth energies as stated by ley line proponents, or its power lies in its astronomical alignments and the human effort invested in its creation, Stonehenge remains a potent symbol of ancient wisdom and connection to cosmic rhythms. Sacred landscapes. Sedona and Uluru. In the American Southwest, Sedona, Arizona is renowned for its stunning red rock formations and its reputation as a spiritual vortex. Located at around 34.86 degrees north latitude, many believe this area possesses concentrated Earth energy. People travel from all over the world to experience these vortexes, which are said to be sites where energy is either flowing into the Earth or projecting out of it. These energies are described as being uplifting, creative, or healing. Sedona is known for enhanced meditation, healing, and psychic experiences, and some visitors even describe seeing orbs and light anomalies. Popular vortex sites include Bell Rock, Cathedral Rock, Airport Mesa, and Boynton Canyon, each with its own purported energetic signature. The geology of Sedona is certainly striking, with its vibrant sandstone cliffs sculpted by wind and water over millions of years. The presence of iron oxide gives the rocks their distinctive red hue. Some suggest that the high concentration of quartz crystals in the sandstone might contribute to the area's perceived energy, as quartz is known for its piezoelectric properties, generating an electric charge under pressure. While scientific studies haven't confirmed anomalous energy fields, the subjective experiences of countless visitors and the beliefs of local spiritual communities have firmly established Sedona as a modern energy hotspot, deeply intertwined with sacred philosophies. Halfway across the world, in the heart of Australia's red centre, lies Uluru, also known as Ayers Rock. This massive sandstone monolith, at approximately 25.34 degrees south latitude, is sacred to the Anangu, the local Aboriginal people. For them, Uluru is not just a rock, it is a living, breathing entity, central to their Chukurpa or Dreamtime creation stories. The rock itself is crisscrossed with caves, waterholes, and ancient rock art, each telling a part of these ancestral narratives. Its immense presence dominates the flat desert landscape, changing colors dramatically at sunrise and sunset. The Anangu believe that Uluru is a major spiritual energy point, a place where the ancestors left their mark and their power. The paths around Uluru follow ancient songlines, which are essentially invisible pathways connecting sacred sites across the continent, similar in concept to ley lines. The cultural and spiritual significance of Uluru is profound and internationally recognized. While geologists explain its formation through millions of years of erosion and uplift for the Anangu, its power comes from the Dreamtime. Uluru is also said to emit a low-frequency hum detectable by scientific instruments. Uluru stands as a powerful testament to how a specific location, defined by its unique geology and coordinates, can become a focal point of deep spiritual energy and cultural identity. Enigmatic zones. The Bermuda Triangle and Earth's mysteries. Few places on Earth capture the imagination quite like the Bermuda Triangle. This loosely defined region in the western part of the North Atlantic Ocean, roughly bounded by Miami, Bermuda, and Puerto Rico, has become infamous for the alleged mysterious disappearances of ships and aircraft. Countless stories and theories have emerged, ranging from rogue waves and human error to more explanations involving extraterrestrial abduction or unknown energy fields. The coordinates of this area, roughly between 25 to 30 degrees north latitude and 65 to 75 degrees west longitude, place it in a region of complex weather patterns and strong ocean currents like the Gulf Stream. While many of the disappearances attributed to the Bermuda Triangle can be explained by conventional causes, severe weather, navigational errors, equipment failure, or even piracy, the mystery persists. Some theories propose that unusual geomagnetic anomalies in the area might interfere with compasses and electronic equipment. Others suggest that large releases of methane gas from the ocean floor could reduce water density, causing ships to sink suddenly. While scientific investigations have largely debunked the idea of the triangle being statistically more dangerous than other heavily trafficked ocean areas, it remains a potent symbol of Earth's unexplained mysteries. Beyond the Bermuda Triangle, there are other locations around the globe often referred to as areas of unusual phenomena. These are sometimes linked to patterns in Earth's supposed energy grid. For instance, the Dragon's Triangle, or Devil's Sea near Japan, is another area with a reputation for mysterious disappearances, often compared to the Bermuda Triangle. Proponents of Earth grid theories sometimes map these enigmatic zones, suggesting they fall at specific nodes or intersections of these global energy lines. However, rigorous scientific evidence is generally lacking. It is important to approach these mysteries with both a critical and open mind. The Earth is a complex and dynamic planet, and there are still many things we don't fully understand about its geological and atmospheric processes. While mystery often surrounds places like the Bermuda Triangle, studying these areas can sometimes lead to scientific discoveries about oceanography, meteorology, or geology. The allure of these enigmatic zones lies in the unknown, reminding us that our planet still holds secrets and the interplay of its various forces. Solar, geomagnetic, and geological can sometimes create conditions that challenge our understanding. Harnessing Earth's power. Modern science and future energy. As we explore Earth's energy hotspots, both scientifically and mystically, we gain a deeper appreciation for our planet's dynamic systems. Modern science is increasingly focused on understanding and harnessing Earth's natural energy sources in sustainable ways. The distribution of solar energy, so clearly linked to latitude and axial tilt, is paramount for renewable energy strategies. Solar farms are most effective in regions with high solar insolation, areas near the tropics or deserts with clear skies. The global grid of latitude helps us identify these prime locations for capturing the sun's power. Geothermal energy, tapping into the Earth's internal heat, is another promising avenue. This heat is more accessible in tectonically active regions, often found along plate boundaries or areas with volcanic activity. While not directly tied to simple latitudinal hotspots in the same way solar energy is, understanding Earth's internal structure and heat flow, which contributes to the geomagnetic field, is crucial for locating and utilizing geothermal resources. These resources can provide a consistent and reliable source of clean energy, contributing to a more sustainable future for our planet. Concepts like ley lines and the scientific study of Earth's magnetic field and its anomalies is ongoing. Understanding how the geomagnetic field interacts with solar radiation and protects our planet is vital. Furthermore, precise knowledge of local magnetic variations is important for navigation and geological surveys. Though not considered energy in the sense of power generation, the geomagnetic field is a fundamental energetic aspect of Earth that scientific instruments can map and study, revealing more about our planet's complex inner workings and its interaction with the solar system. Ultimately, whether we look at specific latitudes bathed in intense sunlight, geological features that concentrate geothermal heat, or ancient sites revered for their perceived spiritual power, the concept of energy hotspots highlights the diverse ways energy manifests on and within our planet. As we move forward in the 21st century, our ability to understand these energy distributions, from the vast scale of solar input across latitudes to the localized potential of geothermal vents, will be key. By combining scientific inquiry with a respect for the natural world, we can develop innovative ways to live in harmony with Earth's energies. Thank you for joining us on this journey into latitude, longitude, and ley lines as we delve into Earth's powerful energy hotspots. If you'd like to continue exploring the fusion of science and spirituality for yourself, visit our Mystics and Metrics blog on our website at fusionofknowledge.com.